Hello guys, in this video I'm gonna talk about degrees and radians, the two frequently used units for measuring angle. Let's start with degrees. The history behind degrees is not that clear, but according to a theory, ancient astronomers believed that the sun was following a special ecliptic pattern, which was repeated every 360 days. So they believed that a year was 360 days. According to that, they made a special pattern. They divided the whole circle into equal 360 parts, and the angle subtended by each portion was called a degree. So let's do it. Let's take a circle and then select a small portion, which is 1 over 360th of its circumference. It is called 1 degree. So we can define it. 1 degree is the angle subtended by an arc of a circle having 1 over 360th of its circumference. Based on this, we expect the whole circle to be 360 degrees. But radian is a different story. Let's do it from the beginning. Suppose that this circle has a radius of r. Then I take a special angle which is subtending an arc with the length same as the radius. Means that the arc length is equal to the length of radius. So the angle subtended by that arc is exactly 1 radian. So 1 radian is the angle subtended by an arc of a circle having the same length as the radius. In general, let's say the arc length is s and the radius is r. So the ratio of s over r is the angle in radians. Okay, let's rearrange the equation and write it s equals r theta. I should tell you two main important points. First, is s equals r. Again, we go back to the definition. So theta will be r over r, which is 1 radian. Moreover, the size of the circle is not important at all. If you enlarge the circle, the arc length and the radius will be magnified simultaneously according to the same pattern. So the ratio will remain the same. The size of the circle is not important at all to define 1 radian or the value of an angle in radians. Okay, let's find pi number in a circle. I'm gonna cover half of the circle with radians. Let's put some radians to cover it. I put 1 radian here. No, I need one more. I put one more. No, I need one more again. Oh, still it's not enough. I still need a little bit more. This a little bit more is 0.14 approximately. So for covering half of a circle, I need 3.14 radians approximately. This is approximate value of the pi number. You know that pi is irrational number and you cannot find all the digits after the decimal point, but approximately is 3.14. Based on that, you can infer that the whole circle will be 2 pi radians. I have a surprise for you. Circumference of a circle. Ask your friends to start from here and they can go round the circle just once. If they go back to the initial position, the distance traveled will be exactly the circumference of circle. So based on the definition of radian, theta was s over r, you know. Round the circle, theta will be 2 pi. So s will be 2 pi r. That's all. This is the famous formula we use for finding the circumference of a circle. Can we convert radian to degree? Of course we can. It's very easy. Let's make a proportionality. Theta in radian here, theta in degrees here, okay? And here I put pi, for instance, for half of a circle. Corresponding value for half of a circle in degrees will be 180. That's all you know. So you can solve it and then write theta in radian over pi will be theta in degree over 180. That's all. You can always use this proportionality to convert the values from radian to degree or degree to radian. For instance, 2 pi is round the circle. In degrees, it will be 360 degrees, you know. Then I divide it by 2. it will be pi, half of a circle. 360 is also divided by 2, it's 180. Again, divided by 2, it's pi over 2. It's equal to 90 degrees, a quarter of a circle. And then pi over 3, accordingly, let's divide pi by 3. And so we should divide 180 by 3 again. So it's 60 degrees. Let's divide pi by 4. 180 also by 4 will be 45 degrees. Let's divide pi by 6, and also it will be 180 divided by 6. 30 degrees. That's all. It's very easy. Moreover, how many degrees will be equivalent to 1 radian? It's not that complicated. Let's use the equality, the proportionality we had. Theta in radians over pi will be theta in degrees over 180. Then I put 1 instead of theta in radians because we are going to find how much is 1 radian in degrees. Okay, so solve this proportionality for degrees. It will be 180 over pi, which is approximately 57.32. It is not exact value according to the nature of pi. You know, pi is irrational number, but it's approximately 57 degrees. Okay? Let's continue with measuring quarters of a circle. Let's scan a circle quarter by quarter. I start from here. Then I go for 1 quarter. Here I will have 90 degrees, which is pi over 2. Half of a circle, you know, 180 degrees, which is equivalent to pi. And then I go a quarter more. It's 270 degrees, which is 3 seconds of pi. And if I go back to the initial state, it will be round the circle, which is 360 degrees or 2 pi in radians. Let's have a flashback to previous lessons. You remember that a right angle is an angle subtended by a quarter. So right angle will be 90 degrees or pi over 2, the measure of a right angle, okay? Acute angle necessarily will be smaller than 90 degrees or smaller than pi over 2. An obtuse angle greater than 90 degrees or greater than pi over 2 radians. Let's continue by defining supplementary angles and complementary angles again. You know that if you divide a straight angle into arbitrary angles of alpha and beta, alpha and beta will add up to make a straight angle. So alpha plus beta will be 180 degrees or pi radians. Complementary angles will add up to make exactly a quarter or 90 degrees. So alpha plus beta will be 90 degrees or pi over 2 if they are complementary angles. Many thanks for watching this video again. See you in the next video.